Welcome to the session. I am Dr. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to discuss on the Module 1, which is the battery chemistry. We are going to see what is electrochemistry and what is the conductance and what are the conductors and about the electrochemical cells called galvanic cells. We are going to see in detail. So, the topics we are covering are the first fundamentals of electrochemistry, the electrolytes and what are the conductors and what is electrical resistance in terms of Ohm's law, and conductance and electrolytic cell and electrochemical cells. The electrochemistry. It's a branch of physical chemistry which deals with the study of conversion of chemical energy into electrical energy. So the conversion of the chemical energy into electrical energy and vice versa, and electrical energy into chemical energy is the electrochemistry. It's a branch of science which deals with this conversion of chemical into electrical. So here, if we see in this, here the chemical ions like zinc and copper ions present in the chemicals, energy is converted into the electrical energy. So, it's a study of electricity and how it relates to the chemical reactions involved in these systems. So, the electricity can be generated by the movement or the flow of electrons from one element to the another. So, if it is a zinc and copper, so the movement of electrons from one to another, from zinc or copper to zinc or zinc to copper. So, here the movement of electrons causes the generation of the electricity. So, this is that type of movement of electrons is called the oxidation redox or the oxidation reduction reaction. So, the loss of electrons is the oxidation and the gain of electrons is the reduction. If both are happening simultaneously, then it is called a redox reduction or oxidation or reduction reaction. Both oxidation reduction reaction are also called as the redox reaction. So, this electrochemistry deals with the flow of electrons. So, it relates to the flow of electrons. It is from chemical and electrical energy. So, if it is the chemical energy is converted into the electrical energy, then it is the galvanic or voltaic cell. Here, electrical energy is converted into chemical energy, then these are the electrolytic cells. So, the electrolytic cells will be like this and the galvanic cells will be like this. Means it is separated by the salt bridge and two different anodes will be present. So different solutions will be present. One acts as a cathode and one acts as an anode. Whereas in electrolytic cell, so here these electrodes are different and the molten some NaCl or electrolyte solution will be present in this type of cells. So if it is chemical, energy is converted to, so chemical to electrical. Here, electrical to chemical energy. So, this is the difference between the galvanic cells and electrolytic cells, where in the galvanic cells, the chemical energy is converted into the electrical energy, whereas in electrolytic cells, the electrical energy is converted into the chemical energy. So, coming to the conductors. So, what are the conductors? So, the conductors are the substances which conduct electric current or the process of electric current or it conducts electricity through it are called the conductors. So, metals such as copper, silver are good conductors of electricity. So, the first place is copper, then this is first place is silver, then copper, gold and aluminium. So, first place is silver, copper, aluminium, gold and beryllium, calcium, magnesium, rhodium, sodium and iridium. So, based on the conductivity of this, based on the conductivity of the electricity, silver is the best conductor of the electricity, followed by the copper. So, here if we see, based on suppose steel, so the light is glowing wood because it won't conduct electricity. So, there is no light here. So, if it is glass, So if it is copper, the conductivity is more. So if we can see, the based on the passage of electric current through it, they act as a good conductors. Those substances which conduct electricity are called conductors. So what are the types of electric conductors? There are different types like metallic conductors and electrolytic conductors. Coming to the first type of conductors called metallic conductors. So the metallic conductors, they conduct electricity or electric current by the movement of electrons without undergoing any chemical change during this process. So they conduct electricity in both the solids as well as in the molten state, means the semi-solid or liquid state. Example, all the metals and graphites comes under this metallic conductors category. Coming to the next, electrolytic conductors, they are the substances which conduct electricity by the movement of the ions in the aqueous solutions. They does not conduct the electricity in solid form. Here in the metallic conductors, both the solid as well as the liquid, means molten state, it conducts electricity, whereas the electrolytes which occurs only in the aqueous solution, not in the solid forms. So the metallic conductors conduct electricity through the flow of electrons, through the movement of electrons, are called the metallic conductors. The electrolytic substances are which allow the electricity to pass through in ionic or aqueous solutions. They are called electrolytic conductors or electrolytes, and the process is called the electrolytic conductance. Again, these metallic conductors, so if we see here, this good conductor means the flow of electron is more. Here in semiconductor, the E is the electrons. So the flow of electrons is more in the good conductor. So the metal, this copper and silver comes under the category of good conductors. If it is a semiconductor, the electron flow will be less. So it partially conducts electricity. Suppose silicon. And if it is a non-metal or glass or wood, it won't conduct electricity. It acts as a non-conductor, also called the insulator, because of lack of movement of electrons or flow of electrons. So this is the non-conductor or insulator, or also called as an insulator. So for example of these electrolytic conductors are sodium chloride, NaCl, and potassium chloride, so KCl, and acids like HCl. So these conductors are copper, graphite, all other metals, gold and waters are the good conductors of, so these are the good conductors of electricity. So what are semiconductors? So these are the substances which partially conduct electricity, because the electron flow will be very less compared to the good conductors. So compared to the metals, the less electron flow will be there. So they conduct the electricity very partially. Example, boron, silicon and aluminium comes under the semiconductors category. The next is the non-conductors. So those substances which do not allow electric current to pass through. No electrons, no flow of current. So they are called non-conductors, are also called as insulators. Example, wood, plastic, glass, rubber, etc. comes under this insulator or non-conductors category. So what are the differences between the metallic and electrolytic conductors? So this is due to the migration of electrons, and this is due to the migration of electrons only in ionic or aqueous solutions called as fused electrolytes. The examples are acids and bases. Here the examples of metallic conductance is metals and graphite. So the passage of current is due to the electron flow. There is no chemical reaction takes place because of this flow of electrons. Whereas here the movement of ions in the ionic form takes place, but it involves the chemical reactions. Means there is going to change the reaction. They are going to change the state of the reaction, and the chemical reaction is going to takes place. So the free electrons are responsible for the electrical conduction. Here the free ions, because it is in ionic form. So suppose NaCl means it is splitting into Na plus and Cl minus. So this causes the electricity passes. So these are responsible for electrical conduction. Mass is not transferred. Here both the anode or cathode are constant and mass is not transferred. Only electrons are going to transfer. This causes the electricity generation, whereas here mass is transferred. With increase in temperature, the resistance increases and conductance decreases. So here temperature means increase means resistance increases and conductance decreases. Here with increase in temperature, resistance decreases and conductivity increases. So this is reverse. Here this is resistance is increasing, here resistance decreasing, here conductance decreases, here conductance increases. So with a temperature increase, this resistance and conductivity differs in both metallic as well as electrolytic conductors. So coming to the Ohm's law, which is for the voltage across the conductor is directly proportional to the current flowing through it. So here it is provided at physical conditions like temperature, and which remains constant. So V is the voltage and I is the current passing through it. So the V is directly proportional to the I. So if the voltage is high and the current flowing through it will be high. So it is R is the proportional constant called as resistance. V is equal to IR, and R is, if R comes here, then V by I. So V is the voltage, I is the current, R is the resistance. So units for resistance is ohm. If we see here V and I, so the V is V equal to I by IR and R is equal to V by I. So V is equal to I into R. To find R, so this is like relation, we can calculate based on the R or I value or the voltage value, we can find it this one. So the units for this electrical resistance is ohms. So what is electrolyte? So the electrolyte is a substance which conduct electricity when it dissolved in aqueous solution. So when it is mixed with the water, suppose electrolytes are mixed with water, it forms an ionic solution. These electrolytes will easily dissolve in the water, which forms aqueous solution. So which forms an aqueous solution, so which conducts electricity. So it is, if it is a non-electrolyte, weak electrolyte, strong electrolyte. So like here in the electrolyte there are three types. So if electrolyte means it should form anions or cations. It should be able to produce anions and cations. These are responsible for the conductance of electricity in the solutions. So plus and minus ions should be there. So here this plus and minus ions, if it is more, the electricity conductance will be more and it acts as a strong electrolyte. If the ion formation is less, then it acts as a weak electrolyte. If there is no ion formation, then it acts as a non-electrolyte. Same as conductors, semiconductors and non-conductors. Here non-electrolytes, weak electrolytes and strong electrolytes. There in that these conductors, semiconductors, here the flow of electron causes the three categories. Here the formation of ions in their solution in their aqueous form causes the three categories called non-electrolytes, weak electrolytes and strong electrolytes. We can see the more ionic formation, this is the current passing through it. So if it is a weak electrolyte, here less ion formation, so the passes will be less. If it is a strong electrolyte, the more electrons will be there and it will causes the flow of electricity. So the strong electrolytes are those which dissociate or ionizes completely in aqueous solution to give constituent ions. Example, inorganic salts like NaCl and KCl. Here they split and forms Na plus and Cl minus ions. Same K plus and for KCl and NaCl. So they split and form Na plus and Cl minus ions, and KCl, K plus and Cl minus ions are formed. They conduct electricity due to the more formation of these ions. So these NaCl and KCl acts as these are the inorganic salts and which acts as a strong electrolytes. And also the strong acid like hydrochloric acid and sulfuric acid. Here also H plus, Cl minus, HSO4 minus, H plus. So these ions are also, they split into H plus and Cl minus ions, and this sulfuric acid, they split into H plus and HSO4 minus ions. Even strong bases like Na plus, OH minus, K plus, OH minus ions. So they split into ions, they conduct the electricity. So here the ethanol, no production of ions because here ethanol is no conductivity. Again KCl because high conductivity because it splits into K plus and Cl minus, and acetic acid solution low conductivity CH3COOH. So it forms CH3COO minus and H plus ions. So this is a low conductivity acid. So here the weak electrolytes are those electrolytes which partially dissociate and ionizes in aqueous solution to give constituent ions. So it splits CH3COO minus and H plus ions. So the ionization will be very partial. So the electricity conductance will be less and the very partial. So they comes under the category of the weak electrolytes. So these are HCl, NaOH and NaCl. So NaCl, HCl, HCl and NaOH are the strong electrolytes. They dissociate and forms ions, positive and negative ions. So what is electrode? Electrode is a metallic rod or bar or strip which conduct electrons in and out of the solution. So what is anode? Anode is the electrode at which oxidation occurs. So anode means oxidation. So loss of electrons. So it sends electrons into the outer circuit. Cathode is the electrode at which cathode means reduction. So this is gain of electrons. So the electrons means plus electrons, here minus electrons. So simple. Anode, oxidation, loss of electrons. Cathode, reduction, gain of electrons. So the electrolytic cell means the device that converts electrical energy into the chemical energy is called the electrolytic cell. So here anode means here loss of electrons, here oxidation, here gain of electrons, reduction, cathode reduction. So what are the difference between the cathode and anode? So cathode is a positive side, here anode is a negative side. So here the reduction reaction occurs, here reduction, cathode means reduction. Reduction is nothing but the gain of electrons. Here anode means oxidation, it is nothing but the loss of electrons. Means here plus electrons, here minus electrons. So electrons move out of the anode, electrons move into the cathode. Here the oxidation, here the reduction and the oxidation, where this is a positive sign and the negative sign. So the next topic is the specific resistance or the resistivity. So what is the specific resistance? The resistance of a conductor is directly proportional to its length and inversely proportional to its sectional area. So here the directly proportional to the length, L is length, and inversely proportional to the specific cross-sectional area. So 1 by A. So R is directly proportional to L by A and it is denoted by the constant which is called the specific resistance. P is equal to, like rho is equal to RA by L. See, this is the rho is denoted by RA is equal to L. See, R is the resistance, A is the cross-sectional area and L is the length. So, if L is equal to 1 and A is equal to 1 centimeter square, then R is equal to rho. Means resistance is equal to the specific resistance. So, then specific resistance is defined as a resistance offered by a material of unit length and unit area of cross section is called the specific resistance. So, and it can be denoted by ohms centimeter. So, here the resistance is, here the current flow. So, it is directly proportional to the length and inversely proportional to the cross sectional area. So, this is directly proportional to the length and inversely proportional to the cross sectional area. So what are the galvanic and voltaic cells? So here they come, as we see in the first slide, these cells comes under the category of, there are two types like galvanic or voltaic cells and electrochemical cells. So these galvanic or voltaic cells are the chemical energy is converted into the electrical energy. So it is produced from a spontaneous chemical reaction. Examples are Daniell cell and dry cell. So the electrolytic cells which convert the electrical energy into chemical energy, it is non-spontaneous chemical reaction. The examples are electrolysis of molten NaCl and recharge process of lead acid batteries. So this is the difference between the galvanic and this electrolytic cell. This is spontaneous. This is non-spontaneous. Here the spontaneous, they draw electrons into cell, means the electrons will be travelled from anode to cathode, and the electron flow, here the redox reaction means oxidation reduction reactions takes place in this galvanic cells, where here non-spontaneous oxidation reduction reaction takes place. So anode and cathode, these are the anode of this electrolytic cell and the cathode of this electrolytic cell. This is the anode of the this galvanic cell and the cathode of the galvanic cell, separated by a salt bridge. So this is the salt bridge between these two galvanic cells. So this here the reaction is the copper. What happens? The zinc loses its electrons. So the zinc loses its electrons. It becomes Zn2 plus 2 electrons. So these 2 electrons will be travelled and reach the cathode, where here cathode, which is the copper, so it gains the 2 electrons and converted into Cu. So the Cu2 plus 2 electrons is converted into Cu. This is the galvanic cell reaction. Whereas in this electrolytic cell, so the 2 chloride ions loses its electrons, which gives the oxidation of chloride plus 2 electrons, where these 2 electrons are gained by magnesium and it is converted into magnesium. So this is the final, like chloride plus magnesium gives rise to Cl2 plus Mg, means magnesium. Here the copper plus 2 plus zinc gives copper plus zinc plus 2 ions. So this is the overall reaction of the galvanic cell. This is the overall reaction of the electrolytic cells. So again, these galvanic cells or voltaic cells are again 3 types. One is primary cells, secondary cells and concentration cells. So what are the primary cells? So these are the cells which acts as a source of energy only as long as the chemical species present in the cell are active. So the cell reactions are irreversible. Then these are designated for only single discharge and cannot be charged again. So the batteries which we are using for a single purpose comes under the category of these primary cells. Example, dry cell and zinc mercuric oxide and this zinc silver oxide. So the batteries used for only single purpose which cannot be recharged. So the cells which we are using in the calculators and the remotes of ACs, TVs are the remote batteries and the wall clock batteries, they cannot be recharged. So the single time usage cells comes under the primary cells category. So what are the secondary cells? So they can be recharged, and this is the difference between the primary and secondary cells. So it is a battery that is designated to be used once and has to be discarded. So reusable. Whereas in secondary cells, we can use it, and after the discharge of the battery, we can charge it again and again we can use. So this is the batteries which we are using in the mobiles, laptops, are all rechargeable batteries, comes under the category of the secondary cells of voltaic or galvanic cells. So this is not reversible, and this is the reversible and fully charged, and so here these cells can be charged and can be used. So this is the anode and the cathode. So once charged, here it will discharge, again charge. So it acts as it gains the energy and again it can be used. So these are the chargeable The secondary cells are the chargeable and can be used and again by charging. The cell reactions are reversible, whereas in primary they are irreversible. So discharging, it behaves like a voltaic cell and it converts the chemical to the electrical energy. So when it is charged, the electrical energy, because we are supplying the power, so the electrical energy is converted into the chemical energy. So example for these secondary cells are lead acid battery, nickel cadmium cells and lithium ion cells. So here what happens, first discharging means the reaction means the chemical energy. The chemicals present in the battery will convert the chemical into electrical energy. So once discharged, again by supplying the current, we are converting the electrical energy into the chemical energy. So charging and discharging. Coming to the third type of cells called concentration cells. So they are metal dipped in an electrolyte, the same electrolyte, and it forms a two half cells. So copper, and here the copper and copper, different concentration of metal ions, but the concentration will be different. Here if we see, this is 0.1 m CuSO4, here 1 m, 1 molar copper sulfate, here 0.01 copper sulfate. So these are the rechargeable batteries in the laptops and the earphones or earbuds. We can be charged and again we can use. So the reaction is charging, means the chemical energy is converted into electrical energy. When it is discharged, when it is charging, we are supplying the current, the electrical energy is converted into the chemical energy. So what is the difference between the electrochemical cells and the electrolytic cells? Means the galvanic cells and the electrolytic cells. So this is the chemical energy is converted into the electrical energy. Here the electrical energy is converted into the chemical energy. The anode is negative and cathode is positive. Here the anode is positive and cathode is negative. So the salt bridge is required in between the anode and cathode. Here there is no need of salt bridge. Salt bridge is not required. This process is reversible and spontaneous. Whereas in electrolytic cells, this reaction is irreversible and non-spontaneous reaction. Here the final EMF, electromotive force of a cell, is positive and the electromotive force of a cell is negative. So what is the electrode potential? Here the electrode potential is when a piece of metal is placed into a solution containing its own ions, a potential difference exists between the solution and the metal. So there will be electrode potential between the metal and the solution. So that difference is known as the electrode potential of the metal or of this single electrode system. So it depends mainly on the concentration of the ions present in the solution or the concentration of the electrolyte we are using in the solution or the nature of metal, electropositivity of the specific metal and temperature of the solution. So this electrode potential depends upon the concentration and the nature of the metal electropositivity and the temperature of the solution. Coming to the single electrode potential. So each electrochemical cell is made up of two electrodes. At one electrode, electrons are evolved. At another electrode, the electrons are consumed. Means the one losing and one gaining. So each electrode dipped in its salt solution is called half cell. So the electrode dipped in the respective solution is first termed as the half cell. The potential of half cell is called the single electrode potential. So there are two electrodes. This is one half cell and this is one half cell. So the potential difference when dipped in the solution is called the half cell. So this is the single electrode half cell. Here the potential difference between the electrode and the solution is called the electrode potential. So if it is for a single electrode, then it is called the single electrode potential. Here zinc is dipped in the zinc sulfate solution. So the electrode potential difference between this electrode and the solution, here zinc is electrode, this is solution. Here copper is electrode, copper sulfate is solution. So the electrical potential between this electrode and the solution is the electrode potential. If it is for the half cell, then it is called the single electrode potential. If it is for the half cell, so the zinc in zinc sulfate solution, then it is called the single electrode potential of this half cell. The half cell means the zinc and zinc sulfate. So when each electrode dipped in a salt solution is called the half cell. So here E cell is equal to E right minus E left, and E cathode or right or left, or otherwise we can mention it as E cathode minus E anode. So coming to the galvanic cell, it is made up of two half cells. So the galvanic cell is made up of two half cells. One is oxidation or anodic half cell. The other is reduction or cathodic half cell. The first half cell consists of zinc electrode dipped in zinc sulfate solution, and this is zinc in zinc sulfate solution. And second half is copper electrode in copper sulfate solution. So, and the second half cell consists of electrode dipped in, this is the electrode which is dipped in the copper sulfate solution, and zinc electrode which is dipped in zinc sulfate solution. So, the both half cells are connected externally by salt bridge. This is the salt bridge. This is the salt bridge. So, here externally and metallic conductors and internally by salt bridge. So it provides the electrical contact between this. Here there is a contact between the two solutions which are zinc sulfate and copper sulfate solution. There is a contact between the two solutions. It acts as a bridge. So it provides the, mostly this salt bridge will be the molten NaCl. That's why we are naming NaCl means salt. That's why we are mentioning as it a salt bridge. It provides electrical contact between the two solutions like zinc sulfate and copper sulfate solutions. So the following reaction takes place in the cell. What happens first? If we see here, the zinc loses 2 electrons. So the 2 electrons go and attaches here. See here, these 2 electrons travel and reach the copper. So the copper Cu plus 2, here zinc gives rise to Zn2 plus 2 electrons. Here the 2 electrons, copper gains Cu2 plus and 2 electrons, then it gives copper. So this is the overall reaction. So here zinc and Cu2 plus 2 electrons. So plus Zn2, here Zn2 plus and copper. So reduction reaction takes place, means oxidation and reduction reactions both takes place in these reactions. So zinc loses its electrons, means oxidation. The copper gains its electrons, means reduction. So this is a redox reaction. Here cathode, so here at anode, this is anode and this is cathode. So at anode, zinc plus 2 and 2 electrons, and cathode copper plus 2 and 2 electrons, it gains and converted into copper. So oxidation reduction, both the overall reaction is this redox reaction. This is about the galvanic cells and the cathode and anodic reactions, which is like the loss of electrons and gain of electrons, which are connected internally by a salt bridge. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.